All right, welcome to video number 2. Video number 2 is actually going to start with problem 1 because I messed up a little bit in my graph especially. So this is a little bit wrong, and actually my vertex is a little bit wrong as well, because you might notice that negative 8 divided by negative 16 is not negative 1/2, it's positive 1/2. So if I take my positive 1/2 and plug that in for x, then I get 8 times positive 1/2 squared minus 8 times positive 1/2 plus 6. And that actually should be at positive 1/2 comma 4. Like I said, that's going to change our graph a little bit here. So that's why I X'd that out a bit. Let me see if I can find a good graph grid for you guys. Instead of here's a good graph grid. So again, we know our y-intercept is at 0, 1, 2, 3, 4, 5, 6. We know that our vertex is at 1/2, 1, 2, 3, 4, right there. Our axis of symmetry has to go through it, and we can reflect it over there. So number 1 should actually be something a little bit more like that. That's your real number 1. All right. So I apologize for that. Coming back to number 7. Write the equation of a quadratic function that passes through the point 14, 4 and has x-intercepts at 2, 0, and 4, 0. 2, 0, and 4, 0. Those are intercepts, so that's my p and q numbers. I'm going to use the formula y equals a times x minus p times x minus q. So if I plug those in, then y equals a times x minus 2 times x minus 4. Now we got to find the a. In order to find a, we need to plug in some numbers for x and y and then solve. Well, we have an x that goes with a y right here at 14, 4. So 4 equals a times 14 minus 2 times 14 minus 4. 14 minus 2 is 12. 14 minus 4 is 10. So we're really looking at 4 equals 120a. We'll divide off that 120 and reduce the fraction, and we get either 1/30 or 0.03 as our a value, whichever one you like better. And then y equals 1/30 or 0.03 times x minus 2 times x minus 4. Whichever one you like better. Number 8. The red angry bird starts on the ground with a height of 0 at time 0. So we have an x-intercept at 0, 0. Reaches a maximum height of 15 feet, so that means my vertex is going to top out at 15 feet somewhere. And then it lands back on the ground after 16 seconds. So if it's back on the ground at 16 seconds, that's the point 16, 0. That is another x-intercept. In order to find the x value of the vertex, we need to find the axis of symmetry first, where x equals p plus q divided by 2, or 16 plus 0 divided by 2, which is really 16 divided by 2. That's 8. So our vertex is at 8, 15. If I use the x-intercepts here, then y equals a times x minus 0 times x minus 16. If I plug in the 8 for x and the 15 for y, then 15 equals a times 8 minus 0 times 8 minus 16, or 8 times negative 8 gets us 15 equals negative 64a. This fraction does not reduce. It also doesn't make a very nice decimal. So if I divide by negative 64, then a has to be negative 15/64. And then I can use that in my formula. I also don't need to say the minus 0 part in here. So my final answer can be y equals negative 15/64 times x minus 16. And that's number 8. Number 9, the height of a rocket is given after x seconds is given by the equation y equals 128x minus 16x squared. Well, first off, that's not in standard form at all. Standard form has the x squared come first. The linear term come in the middle, and if I don't have anything at the end, it's technically plus 0. What is the maximum height reached by the rocket, and how long does it take to get there? They're really just asking, where is the vertex? So the vertex we can find by getting the axis of symmetry first. Axis of symmetry is where x equals opposite of b divided by 2a. If our b is 128, then the opposite of b is negative 128. If our a is negative 16, then 2 times negative 16 comes out to be negative 32. And if I check on my calculator, negative 128 divided by negative 32, we get 4. So our vertex is at 4 comma something. In order to find the something, we need to, so it takes 4 seconds to get to the maximum height. And mostly, I'm just going to plug this in for x. So negative 16 times 4 squared plus 128 times 4 is 256 feet high. Just in case you need that. But vertex is at 4 comma 256. After 4 seconds, we're 256 feet high. Number 10, is this linear, quadratic, or neither? Well, let's see here. 0 to 7.5, we have to add 7.5. 7.5 to 14. 14 minus 7.5, we have to add 6.5. 14 to 19.5, that's 5.5. 19.5 to 24, that's 4.5. 24 to 27.5, that's only 3.5. 2.5, 1.5, 0.5, minus 0.5, and minus 1.5. So that's a long way to go. Those are not the same numbers, so it's not linear. But to get them from 7.5 to 6.5, you have to subtract 1, 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 subtract 1. So if they're all the same on the second, it is quadratic.
I ordered to bring these to you.
Ah, thank you.
Just whatever.
Excellent. Thank you very much.
You're welcome.
All right, so using the table, identify the coordinates of the vertex. The coordinates of the vertex are where we stop adding numbers and start subtracting numbers. So it looks like 16, 32. Also, write the equation of the function. So if it's quadratic, okay, here, vertex is at 16, comma 32. I'm going to use that and then use some of this workspace here. So y equals a times, I've already got my vertex, so I might as well use it here, x minus 16 squared plus 32. And I'll pick any other number here, or any other pair of values here to plug in for x and y. So 30 equals a times 14 minus 16 squared plus 32. If I subtract 32 from both sides and go 14 minus 16 from both sides here, we get negative 2 equals a times negative 2 squared, or negative 2 equals 4a, or divide by 4. A has to be negative 1/2. So we've got our a, we've got our h, we've got our k. So y equals negative 1/2 times x minus 16 squared plus 32. All right, I will come back soon.